Now, part of the reason for doing this is we want to know what y equals 1 over x looks like. So we could plot these. So negative 10, negative 0.1 is here. Negative 5, negative 0.2. Negative 2, negative 0.5. Negative 1, negative 1. Negative 0.5, negative 2. Negative 0.1, negative 10. So if we look at that, that's going to give us a shape, something like this. And there'll be a continuing trend here and here. And then we have 0.1, 10. And 0.5, 2, and 1, 1, and 2, 0.5, 5, 0.2, and 10, 0.1. So over here we're going to get a shape that's something like this, and there'll be a continuing trend along here and here. So there's two parts to the graph, and if we just look at this part to start with, along here it's going to get closer and closer to the x-axis, but it will never reach it. You can't divide 1 by any number at all so that you actually get 0. And if the number is positive, you can't get a negative either, so it's just going to keep getting closer and closer to the axis. And the same's true over here. If you divide 1 by something that's very, very close to 0, but positive, you're going to get a very high positive number. Along here, we can make the same argument, except with negative values of x, and along here, the same argument again. So these lines, the x and y axis, that are approached by our curve, but the curve never gets there, those are known as asymptotes. So the x-axis is a horizontal asymptote, and the y-axis is a vertical asymptote. Now we can certainly plot this graph on the calculator as well. So if we just clear anything we have, and then we need that to be 1 over x, like so, and then we can plot that, and let's make the axes the same as what we had, so negative 10 as far as 10 on the x, and for the y do the same, negative 10 up to 10, and OK that, and you can see we've got a picture that's very similar to what we drew before.